Welcome to multiplying polynomials. So I'll be going over how to multiply them horizontally and also vertically. For our first example, we have a binomial right here, 3 plus 2x, and we're going to multiply it with the trinomial 4 minus 7x plus 6x squared. So here I color coordinated what we needed to do. So some people call it foiling, but I just think of this as a binomial, which means I'm going to distribute two things. I'm going to distribute a positive 3 to the 4, to the negative 7x, and to the positive 6x squared. So if you didn't see the order that I'm talking about, it is closest to furthest. So I will trace it over. I'm going to do, just as I said, 4 first, so 3 times 4, then 3 times negative 7x, and finally 3 times 6x squared. After that is done, I am going to put plus 8x. How do I know it's plus? Because we have a positive 2 here and a positive 4. Then we would put a negative 14x squared, and we would put whatever 2x times 6x squared is, which is 12x cubed. So just to show you what I get, this is what I get. So make sure when you're following along, you try it yourself mentally and see if you get the same 6 terms that I get. How do I know I'm going to have 6 terms? Because I am multiplying 2 terms times 3 terms. You should have 6 terms here. And I left everything in the order that I did. So just to go over it, this is when we distributed the 3 closest to furthest. So that is why they're all going to be underlined in orange. Then this is when I did the pink. I distributed from closest to furthest. So as you can see, there are some things that you can combine. So I highlighted them and I did green for whatever has an x with a degree of 1. So that is negative 21x and positive 8x. And I did highlighted pink for the whatever has a degree of 2. So we have positive 18x squared and negative 14x squared. So those are the only ones we can combine with together. Notice that the 12, which is a constant, has no partner, and the positive 12x cubed does not have a partner. So just to show you what I did here, I brought down the 12, I brought down the positive 12x to the third power, and I combined negative 21x and 8x, just as I said I would, and I got negative 13x. And I also combined positive 18x squared with negative 14x squared and received positive 14x squared. Finally, your last step is to put these in order after combining like terms. So what do I mean in order? You want to do the highest degree in descending order. So in case you're wondering what that means, I have it right here. Notice we did 3, 2, invisible 1, and this is technically x to the 0 power. Because x to the 0 power is 1, 1 times 12 is just 12. So now you can see it is in descending order, 3, 2, 1, 0. And that is how you multiply polynomials. All right, and now I promised I would do one vertically, so here we go. We have x plus 6, which is a binomial, times a trinomial here, 3 minus 8x minus 4x squared. So here I put it in descending order in order to multiply. So let me show you. This right here needed to be changed because it is not in the correct descending order. So what I did was I always make sure that I keep the sign to the left. This is a negative 4x squared, and I know the x squared is the highest degree, so it should be there as a negative. Next, we have negative 8x. Remember, you're always keeping the sign to the left. That is next. And then the constant should always be back here. You might be wondering what kind of sign it is. Since it does not have a sign there, you can assume it's positive, and that's why it would be positive 3 at the end. This always has to be done before you multiply vertically. Next, you have to make sure that this x plus 6 is in the correct order, and it is because it's going from 1 to 0, just as I mentioned before. All right, so now we're ready to multiply. First, what you do is you take your 6 and you're going to multiply it by 3, and you get positive 18. You're going to take 6 and multiply it with negative 8x, and you get negative 48x. Then you're going to take your 6 and multiply it with negative 4x squared, and you get negative 24x squared. Pretty easy. Then you have to continue. So when I continue, I have to make sure I put a placeholder 0, because in this case, we're doing something like 123 times 14, for example. You know, when you multiply the 4, that is kind of what we just finished here, actually. And then you put a placeholder 0 because this is in the tens place, and you would just multiply from there. And after you do that, you would add. So that is what we're doing here. So I'm going to put my placeholder 0, and I'm going to take the x, and I'm going to multiply it by 3 to get positive 3x. Take my x, multiply it with negative 8x to get negative 8x squared. And then x times negative 4x squared, which makes negative 4x cubed. All right, so now that I'm done with that, I am ready to add. So I did 18 plus 0 to get 18. Negative 48x plus 3x is negative 45x. Negative 24x squared minus 8x squared is negative 32x squared. And then this guy had no partner, so you bring him down. So when you do add, just make sure you're adding positive plus positive is still positive. If they're opposite signs, you have to see which one has the higher value and keep the sign. And then like signs you keep and you add. All right, so now we have an example in which I give you this statement and I want you to tell me if it is true or not true. Notice that this is simplified. There's nothing you can do here. But this, you can multiply. You would distribute the A, then you would distribute the B, and you would just make sure that the left side matches the right side towards the end. All right, before I start, I just do want to mention that this right here is called sum of two cubes. And this is very handy when you want to graph a cubic function that happens to look like this, because if you do that, then you would get a factored form in which you can find the x-intercepts. All right, so I'm going to multiply, just as I said, I'm distributive property, the A with the trinomial, and then attached to it, I'm going to multiply B with the trinomial. Okay, so just to make sure you have the correct idea of what I did A times A squared, and I received A cubed. I did A times negative AB, and I got negative A squared B, because there was two A's in that one. Then I did A times B squared, which meant I got positive AB squared. So in this case, you just have to make sure you're not confusing with yourself how many B's and A's you have. Now we have positive B times A squared is positive BA squared. B times negative AB is negative AB squared. And then B times B squared is positive B cubed, because there were three B's in that one. All right, now you're supposed to combine like terms. So I'm going to combine the yellows. Negative A squared B. So negative A squared B is actually common, can be combined with BA squared. So just to show you, A squared B is the same thing as BA squared, because this is commutative property, you can do it in any order. In this case, one of them is negative and the other one is positive. So they actually cancel out. All right, now let's see the highlighted blue. positive AB squared and negative AB squared actually also cancel out. So since they cancel, you'll see that you're left with only actually I'll show you here, a cubed and the b cubed. So then we have a true statement. A cubed plus b cubed is equal to a to the third power plus b to the third power. Same way of saying it, just wanted to mix it up. And so you did prove that it was a true statement. What if you had this example instead, which is happened to be called difference of two cubes? Notice it's difference instead of sum because we have a subtraction sign right there. Okay, so let's see if we can prove that right. Again, we're going to take the a and distribute it. Then we'll take the b and distribute it, and it will be a very long polynomial. It will have 6 terms because I'm doing 2 terms times 3 terms. So let's go over this. First, you have a times a squared, which is a to the third power. A times positive ab is positive a squared b because you had 2 a's in that one. And then a times b squared is positive ab squared. Next, we have negative b times positive a squared is negative ba squared. Negative b times positive ab is negative ab squared because there was 2 b's in that one. Negative b times positive b squared. So you know it's going to be negative because negative times positive is negative, and you had 3 b's in that case. Now we're going to check out the middle. Okay, so notice that the middle, we have the same thing happening just like in our previous one. You have positive a squared b, which is not in the same order as ba squared, but they actually are the same thing due to commutative property. But one is positive and one is negative, so they will cancel. Similarly, you have positive ab squared and negative ab squared. They will also cancel. And so we did prove the true statement because the only thing left here was the positive a to the third power and negative b to the third power, which is what we needed. All right, so now I have a word problem, and I'm going to read it to you. This is a word problem that has to do with physics. So we're going to learn about kinetic energy and potential energy. An object is thrown in the air, has a velocity after t seconds that can be described as velocity equals negative 9.8 t plus 24 in meters per second, and a height h equals negative 4.9 t squared plus 24 t plus 60 in meters. The object has a mass of m equals 2 kilograms. The kinetic energy of the object is given by k equals 1/2 mass times velocity squared, and the potential energy is given by U equals 9.8 times mass times height. Find an expression for the total kinetic and potential energy K plus U as a function of time. What does this expression tell you about the energy of the following object? All right, so that's a lot. So let's see what we can do here. Right, so first, I know I'm blocking it, but that says K equals, remember K means kinetic energy, 1/2 mass times velocity. So I'm actually going to move this one right here. I just want to make sure that you guys understood that from the word problem, I actually had that velocity as a function of time was equal to negative 9.8 t plus 24. So even though I could not just plug in a value squared, I did have a function that I did plug in for velocity. So v was equal to this, so I had to put the whole function in there, which did make sense because we do want our final answer to be a polynomial as a function of time. All right, so this was given to me, and then this is how I evaluated it. So what I did first is I thought of this as 3 entities. as 1/2 times 2 times this whole thing. So what I thought to myself is, why don't I just multiply these two first? I know I cannot distribute inside here because they're contained by squared, but I can just multiply these two as my first step. What is 1/2 times 2? The answer is 1. Then from here, it doesn't matter that there's a 1. I can just worry about what is in my parentheses squared, because remember PEMDAS, and distributing the 1 is negligible, so I'm just going to ignore it for now. All right, so then if you notice my second step to my third step, I just want to make sure that you guys understand that negative 9.8, t plus 24 squared does not mean that you would take the squared and quote unquote distribute. This is terrible. When you have squared, that means you have to write it 2 times and then evaluate it using foiling or distributive property, whatever you want to think about it, like however you want to think about it. So there you go. I just wanted to make sure you understood all of that. Then from here, after distributing twice or FOIL, whatever you want to think about, I did write all 4 terms without combining like terms yet. So now what I'm going to do is I'm going to take your negative 235.2t and negative 235.2t and combine like terms to get negative 470.4t. So that is my kinetic energy done. I know it was a little confusing, but let's go to potential and see if maybe we do a little better. So potential energy, you have, this is gravity, 9.8 times your mass of 2 kilograms. And your height was given to us. It wasn't just a number. Your height that they gave us was as a function of time. And it was negative 4.9 t squared plus 24t plus 60. So in case you're wondering, where did I get this whole function from? It was given to me in the word problem. Then after that, what I decided to do was I thought of this as 3 entities again, 9.8 times 2 times this whole thing as another entity. So I'm going to just multiply 9.8 times 2 first. Once I do that, that's how I got 19.6. Then what I can do is I could take this 19.6 and distribute. And the reason I can distribute is because this does not have a squared or 3 or any kind of exponent outside the parenthesis. So if you do distribute, you will get potential energy equals negative 96.04 t squared plus 470.4 t plus 1,176. All right. So now I am at kinetic energy plus potential energy is equal to, that's exactly what I'm trying to find out. So I took my first polynomial and I put it in parentheses plus my second polynomial also in parentheses, because I want to make sure that you guys understand that there are 2 different polynomials that I'm adding. You already learned this. This was the lesson before multiplying polynomials. Don't forget that when we're adding polynomials, technically there is an invisible 1 here. So you are distributing a positive 1 to everything. But when you distribute a positive 1, it still becomes what it was. And that way you can see that that's what I have, that the negative 96.04 t squared stayed the same. So did the positive 470.4 t and the 1,176. Then from here, reading it from left to right, you have to combine like terms. I know I already crossed these out, but just to show you, this was a positive 96.04 t squared, and it happened to cancel with the negative version of itself. Then we have negative 470.4 t, also can combine like terms with the positive version of itself. It would just cancel out. So the only things left are 576 and 1,176, both positive, and they can combine. So when you do add them, you'll get 1,752. So what does it mean that I had all of these polynomials in terms of time and I ended up with only a constant number. I'll show you right here. Since the sum is constant, this means that the energy of the object is constant and that as it gains kinetic energy by falling, it loses the same amount of potential energy. So that we will discuss in class a little further in case you're confused. All right, so if there's any questions, don't forget you can ask me on Google Classroom or through email. This template was from SlideSgo.